guys, welcome back to the channel. Jag here, and in today's class we're going to continue with our Math 10 content. The topic today is going to be on similar triangles. Okay, we're going to try a few questions from the textbook, and what I want us to focus on is going to be the application questions, okay, involving the similar triangles. So this is actually very important, and it will definitely be on a quiz or a test, okay, that you have coming up. So let's get started. Okay, so I'm going to put example here. So in some of these questions, it just says the triangles in each pair are similar and find the unknown side lengths. Okay, so this is most likely the question the teacher will give you. Okay, so let's try this one. So again, I have two triangles. Okay, so this is A, B, and C. This side is 7 centimeters, okay, 4 centimeters, and 6 centimeters. All right. And you notice that I'm making certain symbols here, okay, which is going to show you which angles are the same, okay, in both of these similar triangles. All right, so here's the second one. So it looks something like this. Okay, and I have F, D, and then 12 centimeters, okay. So what you're going to do here, and this is E, okay. And you do notice, make sure you're looking really carefully, wherever you have the angle, like this is angle F, right across from there, I'm using the lowercase f to indicate the side, okay? So the capital letters represent the angles, and the lowercase letters represent the sides, okay, of the triangle. So as you're looking at these two triangles, let me just actually give you the same symbols here as well, okay? So as you notice, I have two lines, which indicates that angle A is going to be equal to angle D, okay? And there are two dots here, which indicates that angle C is equal to angle F. Does everyone see that? As long as you have two angles that are the same, I know the third angle have to be the same as well, because I can just subtract it from 180 degrees, all right? Okay, so we have three angles that are the same, which is enough to show that both of these triangles are similar triangles, okay? And so what we're going to do, we are looking for the side lengths here. We're going to just write the ratio of the sides, okay? So let's try looking for F here, okay? I want to make sure I'm comparing the two sides of the triangle. So I'm going to do 4 centimeters over F, okay? So again, make sure you compare the two sides, okay, of the triangle. It has to be the exact same two sides. So I see right here, I have 4 centimeters over F, okay? And you have to compare it to two sides that are given for each of the triangles. I'm going to make that equal to 6. So I guess we don't need to put centimeters here. Okay, so 6 over 12. Does everyone see that? Okay, so I'm just comparing sides of the triangles, okay? Make sure you are comparing them in the same order, okay? So here I'm starting with the small triangle. And I want to make sure I do that even over here. I start with the small triangle, which is 6 centimeters, over the big triangle, which is 12 centimeters, okay? So here I'm going to put small over the big, okay? Just so you can see which sides, okay, that you're putting on, because the actual calculation is pretty simple. But if you don't write the ratios correctly, then your answer will be wrong, okay? So but let's just write it on the side here. We are going to just cross multiply because it's quite simple to do that, okay? So I'm going to put F equals, I'm going to multiply 4 and 12. So let's do 4 times 12. I'm going to divide it by the third number, which is 6. Okay, does everyone see that? Anytime you do cross multiply, okay, you multiply the numbers that are opposite to each other, okay, and then you divide it by the third number. Okay, so when I do that, I notice that F is equal to 8 centimeters, okay? Does everyone see that? Are there any questions? All right, good. And so let's just write down our answer here. So this is 8 centimeters. Okay, and we have to do it one more time because I need to find the value of D. Okay, so I'm gonna just take this off. Okay, so again, actually, we could maybe just keep that, okay? Like, let's do the small triangle over the big triangle, okay? So again, I want to compare the two sides that were given to me, okay? So we'll start from here. So I have 6 centimeters okay, which is this side, over 12 centimeters from the big triangle. Okay, does everyone see that? Okay, and that's going to equal to 7 centimeters from the small triangle over D, which is the big triangle. Okay, so again, I don't need to actually write centimeters here, okay, when I plug it into the ratio. I'm going to just cross multiply here, so let's put D equals, okay? So wherever the letter is, okay, don't multiply that first. So here I'm just going to do 12 times 7. Okay, and then divided by the third side. So the third side here is 6. Okay, and if you get a little bit confused, I would just make the arrow. Okay, I always make an arrow like this just to show which two sides I'm going to be multiplying. Okay, so 12 times 7, and we'll divide it by 6. And we are getting D as 14 centimeters. Okay, does everyone see that? Okay, that looks good. And let's just write it in here as well. So 14 centimeters. Okay, one thing you should note actually, okay, this is really important. And the ratio that I'm using is actually always the one that is given to me. So I noticed that the 6 centimeters and the 12 centimeters are given to me in the question here, okay, in the textbook. And that's always going to be the ratio that I'm using to find the other unknown sides. And again, the reason for that is, say over here, we calculated F as 8 centimeters. And I decided I want to use basically the F, and which is 8 centimeters and 4 centimeters from the small triangle. Okay, however, what if you calculated F and the answer was wrong? And now I'm using this wrong answer to calculate the other unknown side. Okay, so again, in that case, both of the answers will be wrong. So I want to make sure I avoid that. Okay, so again, for the ratio, just use the sides that are given to you in the question. Okay, all right, that looks good. So let's go to one of these problem-solving questions. Okay, so I'm just gonna take this off. Okay, and I'm going to actually draw it out on the board here. Okay, so this is from the Principles of Mathematics 10 textbook. Okay, so it says find the width of the canyon. Okay, so I'm going to draw this out. And it does give you the actual diagram. So this is a canyon here. Okay, so it looks like something like this. Okay, I'm looking for the width. This is the width of the canyon. Okay, and I'm comparing it to this other triangle. Okay, that is on the other side. So notice that these two triangles are right angle triangles. And this is most likely going to be the case, especially when you're doing the application questions. All right. Okay, so I'm given some sides here. So this is 22 meters. I have 15 meters, okay, and 160 meters. And I'm looking for the width, okay? So we're going to make the width as x so everyone can see that, okay? And again, always just make the unknown side x here, okay, for the application questions. Okay, so if we're finding the width of the canyon, I noticed that both of these triangles are similar triangles, okay? For triangles to be similar, they don't have to be the exact same size, okay? How I know that these two triangles are similar is because these two angles right here where I put a dot, these are opposite angles, okay? Then I also noticed that I have a 90-degree angle as well. So I know that, let's put an X. I know that these two angles have to be the same, okay? Because I'm just going to be subtracting the angles from 180 degrees. Does everyone see that? So this is basically the angle theorem, which does show that these two triangles are similar triangles. Okay, so with that, all you need to do is write out the ratio. Okay, so you're going to start off with x over this side, which is 15. Okay, and again, just notice I'm comparing basically the two sides of the triangle. Okay, and when you compare it to this is the base of the triangle. So it's going to be 160 divided by 22, which is right here. Okay, so I can see I'm comparing the side of the triangle to the base of the triangle. All right, and again, we're just going to cross multiply this. So I'm going to write it right here. So x equals, okay, 15 times 160. So I'm cross multiplying, and you're going to just divide it by the third side, okay? So divided by 22. Okay, so let's write our answer right here. So again, you could just use your calculator. So we'll multiply it. and we're dividing it by 22, okay? So we're getting 109 meters, okay? So I'm just going to box our answer. So this is our final answer, okay? Again, because it's an application question, make sure you put a concluding sentence at the very end. Okay, so I would basically put, therefore, okay, the width of the canyon, okay, is 109 meters. Okay, everyone see that? And the teacher is going to be looking for a concluding sentence, okay? So please make sure you do add it in at the very end, okay? All right, so with that, let's try this last question, okay? So I'm going to take this off. So again, it's just going to be an application question. And make sure you are practicing those a lot, okay? Because again, one of the sections that the teacher is going to actually be marking you on is application, which includes all of the word problems, okay? So let's try this one. It says, use the dimensions of the Sawyer's triangles to find the width of the river to the nearest meter, okay? So the nearest meter means I'm going to actually round my answer to the nearest whole number. Okay, so I'm going to just draw it out. So it looks something like this. Okay, so this is a river. Okay, so I have like a triangle right here. So it looks something like this, okay? And again, there's a smaller triangle on the other side, which looks like this, okay? All right, and it's the sides are given here, which is 50 meters. Okay, and I have 15 meters and 17 meters, okay? So it looks just like this. We're looking for the width of the river. So I'm looking for this side, which is x. Okay, again, I just always put x, okay? It's just much easier that way, all right? And again, I do notice that these two angles are the same here because they are opposite angles, okay? These two angles are 90 degrees, and I'm going to put an x here. Okay, which means where I put the x, those two angles are the same as well. So again, for all of these application questions, you're usually always using right triangles. Okay, so let's write the ratio for this. So I'm going to start off with x here, okay? So I'm going to put x over the base, which is 15 meters. Okay, and here I'm doing the ratio of the big triangle to the small triangle, all right? And on this side, the base of the triangle for the big one is 50, okay? Over, let's underline it, the base of the triangle for the small one is 17. Does everyone see that? Again, make sure you are looking and checking twice, okay, when you're writing out the ratios. If the ratios are wrong, your answer is just going to be wrong, okay? We are going to cross multiply this. All right, so x equals 15 times 50. Okay, and you're going to divide it by the third side. So I'm going to divide it by 17. Okay, so let's put that into our calculator. So 15 times 50 divided by 17. Okay, so we're getting 44.12. We are going to round that to 44 meters. Okay, so again, make sure you're just looking at the question. This question said to round it to the nearest meter. So we're doing the whole number here. Okay, and sometimes the question might tell you to round it to the nearest tenth. So make sure you are rounding it correctly to 1 decimal place, okay? So the question here was just to find the width of the river. So we're going to write therefore, okay, the width of the river, okay, is 44 meters. Okay, you should actually write this out, okay, especially when you're writing meters. Okay, as a general rule in the concluding sentence, okay, make sure you're not using any abbreviations, just write everything out in words, okay? All right, so that looks good, okay? So that brings this class to an end, and I hope you did learn about similar triangles, how to calculate for the unknown sides, as well as the application questions, all right? And so if there are no questions, we are going to stop right there. Okay, and thank you for watching this video, and please make sure you do like, share, and subscribe to the channel, and I will see everyone next time. Thanks, bye.